Knowing more about dark energy will tell us what is the destiny of our universe.
So, what is a cosmic void?
As the name says, one will tend to think that cosmic voids are empty. Cosmic voids are not really empty. It's like less crowded areas of our universe, if you see what I mean. And what is absolutely amazing is that these are, in fact, the largest regions of our universe. And it's only with the last few decades where we can actually build huge maps of the galaxy distribution. And in these maps, we can find those regions with fewer galaxies that are known as cosmic voids.
What can we learn from the voids that we couldn't learn from studying the clusters?
This is an awesome question. Thanks a lot for asking it. So basically, the idea is that we know that our universe is expanding, and this is already super surprising. But what is even more exciting is that a few decades ago, observations started to indicate that the acceleration, the expansion of our universe was accelerating. So not only our universe is becoming larger, and that's already interesting and surprising, but this is happening faster and faster. So our universe is becoming larger and larger, and this is happening at an accelerated rate. And we don't know why. So because we don't know why, we basically believe there may be a component that is called dark energy, which, we really don't understand. And so we say, okay, maybe this component, this dark energy, can be responsible for the acceleration of the expansion of our universe. So taking, the galaxies in the universe, because the universe is expanding, they're being pulled away one from the other. So the universe is becoming larger and larger. And responsible for this will be dark energy. Now, why are voids interesting in this respect? Because by definition, voids are regions where we have very little matter. And if there is one thing that we believe dark energy is that it's not matter. So in some sense, voids are dominated by this component. We know that voids are going to be dominated by dark energy. So if we want to understand why our universe is accelerating its expansion, we need to look into those regions where there is very little matter so that the signal from dark energy can be captured nicely. So those are the regions where we expect to have answers about the most crucial questions in cosmology nowadays.
What would finding out more about dark energy ultimately teach us? Like, okay, if we find out that it's dark energy, is this the kind of thing like, okay, we found it, or does the fundamental knowledge change with that?
Knowing more about dark energy will tell us what is the destiny of our universe, because we know that dark energy is driving this accelerated expansion of the universe. So it's making our universe becoming larger and larger, and this is happening faster and faster. So understanding dark energy means that we can understand how our universe will change.
Do we know how they would have formed? Like, why would these parts of the galaxy, or the universe rather, be empty and other parts would be crowded?
If we think of the primordial universe, there were already tiny regions where there was a little bit less matter, and those regions became emptier and larger, so forming the basis of the structure that we see nowadays. So we call this the large-scale structure of our universe. So looking at the distribution of galaxies, we see that it's not, a uniform distribution in some sense. There are regions where we have a lot of galaxies and regions where we have fewer galaxies. So the regions where we have lots of galaxies are called clusters of galaxies, and then the emptier regions where we have very few galaxies are called cosmic voids. And it makes this beautiful pattern.
But why would it cluster in one area and be empty in another? Like, why wouldn't this all ultimately kind of homogenize over time?
So basically, there are two different effects that are going on. On the one side, our universe is expanding, and on the other side, so it's becoming, larger and larger. And on the other side, we have gravity. So gravity likes to pull things together. So the combination of these two effects actually makes what our universe is seen today. So imagine, for example, that you have a galaxy that is sitting on a very crowded region of galaxies. It's very hard for this galaxy to move away because it's attracted gravitationally by the other galaxies. On the other hand, a galaxy that is all alone inside the void is in some way more free to be attracted towards the local cluster. So you can imagine as, matter wanting to grow those perturbations, those variations in density. And so emptier regions will become emptier and denser regions will become denser.
I feel like this question is going to make no sense. So bear with me a little bit, right? But if we go from the Big Bang, which everything was kind of condensed into one area, and then it expanded, and the voids formed as the universe expanded, are the galaxies in those voids made of something different? Like, why would that area not have stuff in it? Like, is there something different about the mass or whatever that wouldn't have kept things close to it? Does that make any sense?
So generically, it's a very today question because nowadays, because we finally have access to voids, we're trying to understand whether the properties of galaxies inside underdense regions are very different from the properties of galaxies in overdense regions. So it's more the other way around, right? We are finally accessing those voids. We can look at those galaxies with very deep surveys, and then we're trying to understand whether they're different or not. One thing that seems, consensus is that galaxies in voids have a somewhat lower mass. But all these studies are, just starting because void cosmology and even the study of galaxy evolution for void galaxies is something that it's relatively recent, I would say, in the field.
Okay. Even though you basically said, like, we're still figuring out, I'm going to ask the question that probably doesn't have the answer. But why would they have less mass? Like,
Well, in some sense, for example, you can think if I'm a galaxy and I'm sitting in a region where I'm not finding other galaxies, things like mergers of galaxies, which is when you have pure galaxies that become one galaxy, are going to become more rare. So this is the one example of things that could have an impact. Generically, in regions that are known as voids, there is also less matter. And as a matter of fact, matter, and more precisely dark matter, is the seed for galaxies. So if you have less matter, it's also less likely that you have, extremely massive galaxies.
there was something, and then it just kind of snowballed over billions and billions of years. Like, there was something different about them, and then they just didn't evolve the same way that other places did.
Yeah, it's because they were in underdense regions. So the initial perturbation of our universe indicated regions where we had a little bit more matter and a little bit less matter. And this tiny difference that we already see in the primordial universe leads to the formation of structures that we see nowadays.